Okay, great. All right, everyone, welcome back. So I totally know how it works. All right. As I said, welcome back. It's the week 6 now, and I have already released your assessment. I think it's assessment 2. So assessment 2 is a group work. So at the beginning of these courses, I will hope that our students from this week will start looking at your, or always say looking for your group members, okay? So for your group members, I will just quickly go through about your assignments, okay? All right. Okay, so for your assignment 2 and your group project, okay, but before that, I want to open the Zoom link for everyone, just in case, because sometimes the recording of this room doesn't work, so I have to make some double insurance that it was recorded. Okay, all right. And I'm going to record this. Okay, it was recording automatically. All right, so first of all, I want you to have a look at your, let me switch to view as a student. So as your view, so in the modules, you can find here, they have a group material. So within this group materials, you can see there is a procedure, okay? So for this procedure, it actually outlined the due date of your group formation. Okay, so it will include that for the first 7 week, you need to find you're familiar with your classmates, your etc. And then you need to consider about who is the best partner to work with. So for each group, it should be 4 to 5 students, okay? And the group formation, which means you need to inform me, or during the lab, you inform your lab demonstrator about your group members, okay, by next week, okay, by next week, Friday. All right, so I would say that by next week's lab, okay, you can email me or you can inform your lab demonstrator, all is fine, okay? So by week 5 Friday, I will try to randomly group the rest of the students who haven't yet found their group members into one group, Okay, and of course, I will share you your all your group members' information, and please contact them and complete your group pre-action plan, this group pre-action plan, and submit it to your assessment to Canvas submission in, entry on Canvas. Okay, so this pre-action plan needs to be signed by me, or you can submit it first when I can. I can download it from the Canvas, and I will give my signatures as submitted. So that's the thing. Okay, this needs to be done by week 9. As you can see, you need to meet at least once per week from week 9. So from week 9, you need to submit your pre-action plan, and you need to complete your first group minutes. Okay, so the due date for this assessment tool is week 12 midnight. So you still have 4 weeks to work on week 9, 10, 11, 12. Okay, so for 4 weeks, you need to submit one pre-action plan, 4 group minutes, and your final report. Okay, so for the group minutes, I won't check weekly. I will check during your, for example, twice a week. Okay, so just to ensure that you guys are all in the right track. Okay, so by that time, I hope you can submit your group minutes to the Canvas. Okay, or I will check on the Canvas. I will try to give you my feedback. Okay, or you can just directly email me. So always, no matter what, I can accept. Okay, submit via the Canvas or via email. Okay. So this is the pre-action plan. All right. Still process. Try it again. Check it here. Materials. Assess deny, okay. All right. Let me see these group minutes, meeting minutes. Okay, something wrong about this. I will try to check afterwards. Okay, my side here, assignment to pre-action plan. Because pre-action plan, they are the same thing. So I put it in here. No, pre-action plan. This is pre-action plan. Okay, so pre-action plan is look like this. All right, so you need to give your group name. Okay, of course you can name yourself like group 1, 2, 3, 4, 5, etc. Or you can name to yourself whatever name you like. Okay, student number, email. This one is optional. Okay, but I hope you guys can give me your team leader. Okay, so filling these actions. So these actions I will try to track, but I'm not. Always, I will not change any. Okay, so like for another course of mine, I will maybe more take focus on the person's responsibilities. Okay, I will try to see that the responsibility allocated to each student or the task and are quite equal. Okay, so I hope that group work is equally all right, and I might give some suggestions about the person's responsibility and give you feedback. Okay, so this is the only way place that I will change. But for the rest of the records, I will just keep the same. Okay, so after, if I don't have any adjustments, I would just directly sign my names, email you back, or I just directly submit it to the Canvas. there's only one thing I'm not sure is when I submit it on behalf of you, I don't know whether you can receive that version or not. Okay, but if you unable to receive that version, please email me. Okay, just double confirm that the part you allocated, I think, is reasonable. All right, so this is the pre-action plan, and after the pre-action plans for group minutes. Okay, so for group minutes, you need to inform me about not in this detail, but for example, who discussed what. Okay, so if you have some progress or who determined of what. Okay, so for the attendance, I don't care about the time of arrival. Okay, so if you don't remember the time of the arrival, it's totally fine. But I do care whether all the group members have attended or not. If not attended, why? Okay, so it's still in progress, or you guys actually have some casual discussions before the whole group meeting or etc. So it's not necessary that everyone needs to attend. So if you have very reasonable excuse, it's totally fine that you excuse this meeting, okay, the whole group meeting. But the point of thing is, even though you not attend this meeting, but you still need to record what's your current progress, okay? So because when I check your group minutes twice a week, I need to ensure you are on the right track. It's mainly based on your meeting notes. Okay, for example, who points out that this is the direction we need to focus on. So we need to discuss. We need to spend more time to discuss on this period, or your current progress. Okay, so whether your current progress is behind the schedule or is totally fine. So all that I made a decision or whether you are on the right track is all based on the meeting notes, okay? So make sure that even you are not in the meeting, so I hope you can at least give your progress to the team leader, and the leader need to make notes here. All right, so that's the thing, okay? Parking lot, I actually not care about this. All right, so that's the group meeting. All right, so that's all for how to manage this group work, okay? So as I said that this group work, it's due on week 12 Friday. And all these pre-action plan, okay, pre-action plan thing needs to be completed by week 9 Friday, okay, submitted to the Canvas, all right? Another thing I want to mention about is the specification. All right, so the timing that why I released the assessment to this week, because from this week, it's related to your assessment too. Okay, so this week, it's the computer vision. Okay, we'll talk about the computer vision model. And, all right, I hate it. Okay, let's work on here. Okay, so this is the assessment, your assessment too, okay? So it has to be the 4 to 5 students in a group, okay, no more that. If it's less, for example, you only have 2 students, or you want to do it alone, then I might consider to, but you need to inform me in advance, okay? You need to inform me in advance by week 9, okay? So after week 9, the group change only will be permitted only they have like some strong excuse, okay? But otherwise, for example, your group is 2. If it's 4 weeks to complete, for two students to complete 20 to 25 pages, I think is too much. So I would consider to reduce it to 10 to 15 pages, okay, excluding the references and appendix, of course. But it's mainly I will reduce the, for example, here, okay, requirement is For the whole group, normally you need to identify several, is at least 2 identified industries, okay? So if it's 2, I will ask you just identify 1 industry as your case study, okay? That's the group size and the amount or we say the workload. All right, so let's focus on the content. By the way, this 20 to 25 pages, if you have the table of contents, it's the whole page, this page may not be considered within the 20 to 25, okay? Executive summary, I hope you can just with like half page is totally fine with the executive summary, okay? Introduction is normally very important. It includes the background. So the background is including about, the general what task for your report. Okay, for example, this task is actually the computer vision and natural language. Okay, so vision and language model. All right, so this week we talk about vision, next week we talk about language processing. All right. So the background is talking about vision model and language models in the real world, etc. How it's implemented in the real world, etc. So that's the background and your motivation. So for example, you pick up for this report, we pick up the clip. Okay, so the clip, it's the clip. The model is very typical, it's popular, and we can't say state of art, but it is very popular even in the research area. Okay, it learns the vision concept from the natural language supervision. Okay, so the motivations included in the introduction parts, it will be, for example, why you choose these models to solve your problems, okay? And also give some background about the industries you selected. It's mainly about the industry's problems, okay? And why you think these models can benefit for these problems, okay? So for different, because you need to choose at least 2 industry, that's, remember your assessment 1, okay? So assessment 1, you identified about looking for how they utilize their AI technique in their products to help them to increase their service, right? So that can be included in your motivation description. And after that, remember that in assessment 1 requires you to talk about the AI products unique aspects. So this unique aspects, I want you to also include it in this assessment 2's introduction part. You think about when you utilize the AI models in these 2 industries, what's their unique improvements you can provide, okay? So that's the 3rd thing, okay, in your introduction part. Okay, the 4th thing you need to include it in your introduction part is the conclusion, obviously the contribution. So after you apply these models, whether it solved the problems or not, so if solved, how better it improved, okay? What challenge it remains unsolved, okay? So that's all need to be included in the introduction. So let me summarize about the introduction. You need to include 4. 1, background, 2nd, motivation. 3rd one is the when you utilize this model into the different questions for the industry, what's your unique contribution, right? The 4th is the conclusion. So after you implemented this model to these problems, what's the performance, okay? And what's the challenge that remains unsolved? All right, so that's the whole thing about the introduction. So introduction, we can say it's a summary about the whole report, right? So the background description is actually the first part of your introduction, but the background in your introduction is a summary. But in these sessions, you need to give more detail about these industries' problems, what it is, okay? what kind of thing they actually want to solve. And remember, when you describe the problems, I want you to describe as an AI project problem. Remember, in our first 2 weeks, when we describe a problem, I want you to transfer it into an AI project problem. You need to describe the problems about its the target, what's the task, okay? What problems you want to solve. The second one, that we need to solve these problems, what kind of data you have, okay? And when you identify about this, solving these problems, what kind of like data you think it's the high quality, okay? And following on, based on the natural understanding about these questions, you can refer to your our weeks 3 and 4, I think in 5, okay, 3 to 5 week slides you describe about, okay, based on the problem description, what kind of algorithm is better to be utilized, okay, to solve this problem. So you describe about these problems is the logistic regression problem, classification problem, etc., right? So that's the main thing. All right, after that, you talk about applications and impact. So application and impact, because we actually have give you the solution. You don't need to choose the algorithm, okay? We have actually give you the solution, it's the clip. You need to use the clip, all right? And for these applications, you just talk about how you utilize the clip to solve the logistic problems or the classification problems, or if it's a classification problem, what specific classification problem it is, okay? So when we utilize this clip to solve these problems, theoretically, what's the impact, okay? So after you talk about this, you mentioned about the methodology, okay? For different kind of problems, why you want to adjust or we say fine-tune this model, how to fine-tune this model to get a better performance, okay, in theoretical, you need to describe in this section. So after you describe it in the theoretical part, make it proof it works theoretically, and then you give me your experimental evaluation. So in the experimental evaluations, I want you to follow up the methodology you mentioned in the last section, and prove that, okay, so based on your previous, for example, you decided to fine-tune this model, utilize what kind of data sets, and fine-tune this model based on it, okay, when you fine-tuned it, layers you selected, we'll talk about this week, okay. So all these details, and after that, you give the initial performance or the of these models is blah, 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 and you justify whether it's satisfied or not. If not, for example, they have some overfitting problem, they have some underfitting problems, what solution you choose to improve the performance, etc. So these are all in the experimental evaluation part, all right. Okay, so after that, you talk about the advantage and limitations. So based on the evaluation results, you show that, okay, this model, by doing these modifications, can solve this problem. So this absolutely an advantage, right? And after that, you need to consider about the limitations. So limitations, I hope you can consider from the following aspects, okay? So you can go through deep, detailed from here. Okay, so for example, consider about the model's limitations, including the ethical considerations. Okay, so especially when it's in the industry, you can consider about when you do your assessment 1. Okay, so what kind of like ethical consideration or challenge they think about. And as a big company as them, as a very mature service they provided, they have these kind of concerns. It definitely will assist in your application. So please include it as well. And as for the other aspects of the model's limitation, for example, when time goes by, whether the model's performance will drop or not, if it dropped, what's the plan you need to do? So that's another aspect of the model's limitation. Okay, so that's the advantage and limitation. So afterward, the future direction and conclusion, the future direction is mainly based on your limitations. Okay, so based on the limitations you propose, you find what's the possible solution. Okay, so describe in the future directions. Okay, so the future directions, I would suggest you to search about, for example, give more reference in the future direction. Okay, because this limitation is not unique. Maybe it's not unique to, I don't think it's unique, it could be unique to your scenario because this is, they don't have a real scenario cases here, right? So the limitations, you can find the similar limitations in other implementation, AI implementation, right? And they will actually propose their future directions. And you can say that based on their proposal, you believe that these directions, it's provinced or sound to solve the limitations we propose in our last section. Okay, so that's the future directions and conclusion. All right, so that's all. Okay, that's it, and I will, let's check. Yes. I will not talk about the cliff model. So I will talk about the cliff model in details after the week 10, okay? No, week 10 is we talk about the language processing. So perhaps I will talk about the clip model, introduce about these clip models in week 12, all right, if I have time, all right. Sorry, week 11 if I have time, all right. But before that, I hope you can do some research about it. Okay, so for doing this research, I actually provide some references. Okay, so for example, this one is the original paper proposed this model. As you can see, it's quite new. It's proposed in 2021. It's quite new, right? And it's very powerful, strong, a strong one. Okay, I think maybe you're not clear about what it is. Okay, but after the week 10, you probably will understand what I talk about, okay? But for the students that you just need to implement it, you don't very care about this algorithm, etc., you can directly focus on this GitHub, okay? So in this GitHub, it gives you the very detailed guidelines about how to utilize this model with the APIs, etc., okay? Okay, so that's all about your assessment too. And by the way, if you think it's very challenging, you can reach out to me and also let me check. I think that's only for INFT 2060s bachelor students, okay? But yeah, I finally works out, but I no longer need it. Okay. Where is the, I think it's in the announcement. Pass, okay. You can reach out to the Mac, okay? So he will help you to, if you have any difficulties in working on this project, okay? So if you, I don't know, but when he sends you the emails, whether you can reply directly or, yeah, if you don't know his contact, just email me, okay? I will share with you as well. All right, so that's all about assessment 2. Any questions related? Okay, I know you need time to process it. Okay, so if you have any time, email me. All right, so let's go back to the course. I probably need to. All right, I have already spent half an hour. All right, quickly goes to last week's last part because I do remember I haven't yet finished last week's last part. Okay, but that's very important. From where? Generalization. Model fitting, improving the generalization. Now, this week's it's also very important. I would try to copy paste last year's recording, because last year recording I didn't work on the split pieces. So perhaps I introduce more detail about the last part, so you can get more information. But last week I just briefly talked about that, right? So this week is very important, and they do have very large portion of the of your exam. So I don't want to miss anything here, and we need to. I will guide you to do some practice to solve the problems, etc. All right, so. The outline for this week, we talk about the computer vision. We talk about the convolutional neural network utilized in the computer visions. And then we talk about how to train the, this is the convolutional neural network, CNN, okay? And what's the modern CNN architecture pattern is. All right, so the corresponding learning objective aligned with our learning outcomes includes, of course, the you will understand about the computer vision and its typical task. Okay, so by understanding this, when we try to match to your assessment 2, is when you describe about a problem, a real-world problem, you can quickly classify it as what's the specific task it actually belongs to. And after you identify about the type of the task, it's very easy for you to identify about what kind of algorithm you can use to solve the problem. Okay. So, but of course, in your assessment 2, we have already picked up the model for you. All right. The second thing is you need to learn about the convolutional neural network. Okay. So CNN. And why that's especially useful in the computer vision. Okay, so another thing is the RNN we will talk about in our next week. So RNN is especially useful in the language processing. Okay, CNN is useful for the computer vision. Okay, CNN for image, RNN for language processing. Always say the RMM is actually for the time series based data, and CNN is actually for the spectacle information data. All right, so that's the difference. All right, third thing is to apply the CNN to image data in practice, and you show the different approach of the training CNN with the few training data. And this technique, it's what we call fine-tuning, and you don't need to train your models in your assessment 2, but you do need to fine-tuning your model in your assessment 2. Okay, select the best fine-tuning strategy is the main task for your experimental evaluation section. Okay, based on different settings, you will find the best performance about these models in the specific problems. All right. Now, let's focus on the first thing, is the computer vision. So this is the so aim to give the computer ways to gain the high-level understanding of digital image or videos. Okay, it's because the image and videos are all unstructured data. So just recall what's unstructured data. Okay, structured data is organized in rows and columns. Unstructured data, it doesn't follow a predefined format. So that makes it more complex to analyze, interpret, and even difficult for the expertise to extract the characteristic and utilize the traditional machine learning algorithms like the decision tree, etc., to process, to understand this kind of data. So it's unstructured. When we talk about the data, this data is raw and minimally processed. So when we talk about image and video data, we are often dealing with the raw and minimal processed data. So because this data directly comes from the camera sensors, right? So capturing words in its actual natural form, so processing data is extremely meaningful insights, is with the extremely meaningful insights is a significant challenge, and we let the CMM, or we say the neural network, artifactory neural network, to help us do this process. So we say that their information is encoded in the high dimension data with the million of pixels. So, deep neural network are particularly well suited for this type of the data. And one of the earliest and biggest success stories for deep learning, and some products that use deep vision models, including the Google Photos, okay, Google Image Search, YouTube, video filters in the camera app, Telstra's SFP, retail check systems. So all these are their success implementation. I won't give, perhaps just give one, okay? So for example, the Google Photo, it used the deep learning to automatically organize and search your photo library. So it means that you need to understand the context of your photo, okay? After you understand the context of the photo, so that's what we say segment classifications in this model's task, okay? After the segmentation classifications, you organize it. So that's another further classification. So it's understand the context is one CNN model can do. Okay, after you understand this model, that's another traditional machine learning model to do the classification. So this function automatically organize and search your photo library. It at least include two models to help you do this stuff. Okay, so that's the Google Photos. All right. So here are the three typical tasks. So it includes the image classification. The second is image segmentation. And the third one is object detection. So this third type is very important. So in your final examination, I will test you in your quiz and also in the short answer questions, give you a scenario about what's the difference between these three terms. Okay. So for the image classification is mainly to simply to tell the differences, assign one or more labels into one image. Okay, so image segmentation is segment an image into different areas. Okay, and then label different areas. So that's the image segmentation. Okay. Or if it's not a classification task, it's a regression task, we can say, or cluster task that we can say different areas. We try to find the similar patterns. Okay. And third one is object detection. Object detection is different from the previous two, but quite similar. Object detection is try to draw the rectangles around the object of interest. So the first thing is to find out the object of interest and draw the rectangle. So that's the objective detection. So I want to talk about the difference from three aspects for these three types. Okay, for objective, the image classification, it's the different image. So normally you will put different image, and each image you normally consider it as a whole. Okay, no matter how many labels you align with it, you assign to it, the image, it's one image is a whole. Okay, second objective is one image is maybe the whole testing data set. Okay, but the main target is different regions and segments of this image. So that's its objective. And for the object detection, the aim is to identify and locate the object within an interest. So the objective of the object detection task is no longer the whole image or part of the or the segment of the image, but it's the point of the interest. Okay, so the point of interest can be the human's head, face, or hand, or traveling tours. Okay, so any can be this objective. Okay, that's what we say, the points of the interest. Okay, so that's the difference in the objective. The outputs, it's different as well. The image classification's outputs, it could be labels to the entire image. The image segmentation, it could be the mask. Okay, it could be the mask to a few areas assigned, or it also can be a label to the segments of the image. Okay, but for the object detection, the output is what? It's the bounding boxes with the class label. Okay, so that's the objective detection. And the complexity is normally we say the image classification is quite simple, and segmentation, median, objective detection is it's the highest complexity among these three tasks. Okay, so image classification, for example, we'll talk about the case studies here. Okay, so we have for example, single label classification. So for example, here, an image can only be in one category, excluding others. So for example, this can be biking, running, swimming. So for this label, we can't say it's one is biking, in the meanwhile is running, in the meanwhile he's swimming. So that's what we say the single label classification. Okay, but for the multi-label classification, that means the labels you put, each labels you put are in different categories. Okay, so we can say it, we can identify this, the entire image, or we can identify this scenario from the bike, and also from the person's perspective, and also from the tree's perspective. So they are in different categories. Okay, but you can't say that, all right, this person is actually some person with the bike and also with the car. It's possible. Okay, sorry, it's possible. It's possible. Okay, if I have different person, so they may have like multiple persons, someone with the bike and someone with the car. Okay, so the thing is, you need to identify, for example, if there's no persons here, the scenario here you identify, you can't say it's bike, in the meanwhile it's car. Maybe you can. I know it's very confusing, but this is all what I meant. If the label you describe in this scenario, it depends on what scenario you want to describe. Okay, so you assign labels to it. Okay, so this is, for example, when we're searching about the keywords on the Google Photos, right? So the keyword for the Google Photos is the Google Photo. They try to utilize the CMM to understand about the context of this image, or we say the scenario from this image they try to describe. They use a few keywords. By using these few keywords, they utilize the multi-label classification to summarize these few keywords. Okay, so according to this, it will easily for you to summarize it based on their categories. Okay, so that's what we say. Searching for keywords in the Google Photos, and behind the scenes, you will require very large multi-models classification models. All right, that's the image classification. For the image segmentation, the same image here, okay? The goal is to assign the class to each pixel in an image, thus is segmenting the image into the different zooms, okay? So they also have two kinds of the segmentation, including the semantic segmentation and instance segmentation. So semantic segmentation is each pixel is classified into the generic object classification. Categories. Okay. So for example, these two, they are the same person. Okay, so they are in the same category. Okay, so very general category. So that we say it's in semantically, they are the same. Okay, semantically, they are the same. The bike, they are semantically, they are the same. So they are the same label. However, for the instance segmentation, that's different. Okay, instance segmentation, they don't understand the semantic similarities or not. Okay, with two person, that's two individual, that's two label. Okay, they are not the same label as well because they don't involve any semantic understandings here. Okay, that's the instance segmentation. So it actually means each pixel is classified into category to which phrase out individual object instance. Okay, so that's the different things in the between the semantic and instance segmentation. All right, let's focus on the object detection. So object detection, we can say it's quite similar to the instance objection, but what's the difference? Okay, so because this goal is to draw the rectangles called bounding boxes around the object of interest in an image. And each bounding boxes is associated with a class. Okay. And this one bounding boxes, it's actually focused on the instance. However, each instance, they will have their own minutes. Okay, for example, I give them 2 minutes, I mean this, they are the same. And this, because I label it into the same category, that means my interest of the points is the person. Okay, it's the person. So I understand about the person's common category. Sorry, not category, characteristic. Okay, characteristic, the models learn. All right, so if my point of interest is the traveling tool, okay, then I'll try to classify, okay, this is the traveling tool, it's bike, it's car, it's, I don't know, skating board, or etc. All right, so that's the bike. Except for that, they also need to identify about the location. Okay, so that's the difference comparing to semantic segmentation and instance segmentation. They need to identify about the location. So for example, the person's location is within the images X and Y, okay? And bike is in the images X and Y. Okay, so that's the location. All right, so the history of the object detection, including the overfit, that's sliding a location network, okay? It's actually one of the first models to combine the classification, location, and detection in a single framework. So it used the sliding model window approach, while the CM was applied to the different region of the image to detect the objective. Okay. However, this overfit, this algorithm is very computational intensive. So that's why they turn to the region proposed network, RPN. Okay, region proposed network, it's a significant breakthrough because they generated regions proposal directly from the convolutional feature map, making the detection process much easier, much faster. Okay, and the key component is faster RCNN model. Okay, and this is also another benchmark for the objective detection task. Third thing is the YOLO. Okay, is you only look once. YOLO is another revolutionary approach. Okay, it framed the objective detections as a single regression problem. Okay, it's no longer considered as a classification problem, but considered as a regression problem. So YOLO will require the bounding boxes and the class probabilities directly from the full image in one evaluation. So this could make these the YOLO models incredibly fast and suitable for real-time applications. So this is why, well, actually current products, I can't say most, but lots of them to utilize the YOLO or modified from the YOLO. Okay. SSD is a single shot detector. The single shot detector combines the speed of the YOLO with improved accuracy by using a series of convolutional features mapped at the different scale to detect objects. And this will allow the SSD to handle the objects of various size more effectively. Okay, so that's the example about the object detection. And the very typical object detection is the automatic car. Okay, they utilize the object detection to monitor the cars, pedestrians, and signs in view of its camera. All right, except for that 3 class, we also have other classes. For example, the similarity scoring. Okay, so it involves determining how similar two given images are, likely commonly used in the application image retrieval or facial recognition. That's the similarity scoring. Okay. I don't know whether you guys utilize the face recognition. The facial recognition to entering a building or not. I don't know whether you guys have had this kind of experience? No? I don't have much experience in Australia, but when I back to China, there were lots of like facial recognition. And when we normally do the facial recognitions, you show your face, it always will have the rectangular boxing to capture your face. And meanwhile, when you move, it will keep moving. That's the real-time object detection. And in the meanwhile, they will have a very small score under the boxes. It will say, for example, 0.9, that's pass. Okay, for me, because I'm I just occasionally back to my parents' house, so it's normally say 0.3. Deny access. Okay, so that's a very typical similarity scoring. But in the meanwhile, it's also an application of the object detection. Okay. The second is the key point detection. Key point detection, this task pinpoints the specific attributes of interest within an image. So such as the facial features like your eyes, your nose, your mouth. Or sometimes joints in the human body. So for example, they will highlight your elbow, etc. So that's related to the human body. Okay, and it's essential for the application like facial recognition and gesture recognition. So the gesture recognition, for example, I don't know whether you see an AI dancing in a festival or not. Has anyone seen an AI dancing in the festival? No? I highly recommend you to see the Chinese festival. They do imply all these AI implementations in all kinds of like festivals. And I see lots of them a few years ago. And I'm quite interested in that, and I search about their stuff, and actually build on some. The training data is actually built on some. What's they called? It's anomaly actor. They have some actor and actress. They capture the sign, the sensors in their elbows. The hands, their faces, and when they do the actions, in the figure, you can create a virtual character do the same things as well. Okay, so that's what we say the key point detection. So with using this key point detection, it's very easy to keep track on the your gestures, okay, and also with the facial, for example, smile, confuse, etc. That's all the key point detection. All right, post estimation. Okay, I don't have much time. Just quickly go through it. It will estimate the pose of a person or objects in an image, and typically identify the position of the key points or parts. And it's widely used in augmented reality, sport analysis, human-computer interactions, etc. Okay, I do remember we do have some students from the robotic team from our school, and I don't know whether you guys have this, but it may have the pose estimation here. Okay. 3D mesh estimation, this task reconstructs the 3D model from 2D image. So creating a mesh that represents the surface of the objects, and is critical for applications in animations, virtual reality, and 3D printing. So when I mentioned about that animation, for example, we have animation actress and animation actor. So they actually do some maybe during the break, I can show you the videos about it. It is very interesting. I'll ensure it's very interesting. and they actually combine about the key point detection and the 3D mesh estimation, okay, to create an animation. Okay, so that's all. Let's have a break, and I'm trying to search about that video. If you're very interested, keep stayed. But this is not part of the lecture. Okay, okay. Let's have a break for 10 minutes. Sorry, perhaps 5 minutes. I have too many contents later on, so just 5 minutes. Let me search. So I believe they have, this is my, one of my following up. Because this is not part of the course, okay, I don't find an English version. So I just show you about what they are, okay. Can you see it? Focus. Oh, it's not focus. Okay. Ah, I'm quite terrible about this. Do they have automatic stuff?
So you can forget about the lyrics and make no sense. Okay, this one is the animations actress, and this is how they utilize the key detectors and the key detector and the 3D mesh estimation technique to implement it. Okay, as you can see. Okay. I don't know whether you can see it's what it wears. So for example, here what it wears, this is the sensor in its key. This is what we say the key point detection, okay? This is the sensor they're actually wearing. And what else? I don't know whether I have the vision that, let me check whether they have the whole phrases. This one maybe it's more. Okay, never mind. So that's one video that I want to share to show you how the AI implementations in what kind of task they utilized in the in an animation. Okay, welcome back. Now this is the main stuff, okay? That part is just like interesting. I don't consider that part, all right? And that part will not be tested. So during your exam and during your assessments, okay? Forget it. All right, convolutional neural network. It's CNN. All right. CNN are what we say the deep neural network that includes convolutional layers. Remember that we talked about last week, the convolutional layer, what it means. Okay. And they are very, okay, just keep, just want to remind that just in case someone forget it, the convolutional layer is mainly to extract the features from the very massive information, right? Just try to exploiting this spectacle structure of their inputs, okay? So this is what we say, spectacle structure of their input. And based on the feedback, label feedback, they would try to be more parameter efficient, okay? So try to learn the parameters that more focus on the target. And they will try to use the far fewer parameters than a plain DNN with the same inputs. So what's the difference between the CNN and the DNN? What's the real important differentiation between them? All right, let's see the structure of the CNN. Okay, this is a very basic CNN structure. So a CNN structure is normally will include, of course, the first thing, convolutional layer. Okay, the second thing is pooling layer. Third thing is pattern operation. And finally is the fully connected layers. Okay. So for the 2D convolutional layer, it tries to extract the features from the input image. This max pooling layer, it tries to reduce the spectacle dimensions and remains the important features that related to the task. Okay. When you try to combine this convolutional layer and max pooling layer, and you repeat it, is you try to build a deeper feature hierarchy. Okay. By building this deeper feature hierarchy, remember the stuff we showed here last week about the image, we split it. What's meaning about the deeper feature hierarchy? Try to learn more deep information or detailed information related to your task. All right. Deeper feature hierarchy means here you need to split the image into smaller pieces, right? Okay. So pattern layer, pattern operation. Normally I would say pattern layer, but it's not operation. It tries to convert the 2D features map to the 1D vector. They do nothing. It's a format transform. Okay. Lastly is a fully connected layer. Sometimes we will say dense layer. Okay. So fully connected layer often occurs in the here. Okay, dense layer. As you can see, dense layer, dense here. And this dense actually performs a high-level reasoning and output of the final predictions. Okay, so in summary, I will just talk about this simplifies the version of the Alice net. Okay, all right, this one. The first is what we say the input layer. Okay, and this window size is what we say the kernel size, okay? And when it tries to move from up, for example, top right to bottom left, okay, that's what we say it's strike, okay? Sliding step, not strike, okay? Strike is the, stride of 4. Wait a minute. Let me check about the kernel size stride. Oh yes, that's just the step. Okay, that's the step. Stride is the moving step. Okay, and another thing is the padding. Padding, it's for example, when we calculate this, okay, when we try to map this into here, as you can see that they try to map these things, summarize it into the 1 point or a smaller point or smaller, it depends, okay. Summarizing to these, it just try to do, for example, a very simple thing. Of course, it depends on its activation function, but just try to help you understand about this process. For example, just try to average the value, okay? So for this window size, I try to average this value and map it into the convolutional here. All right, remember about for example, average, or what's the meaning about average from previous layer to the next layer from our last week? It means it's from color to black and white, remember? And some is from black and white to color, okay? So it's that kind of thing, all right? So padding actually means when padding is 0, I just only considering about the window size, the features within this window size. But when the padding is 1, I need to consider about one more step over this padding. Over this window size. Okay, that's what padding means. All right. So when we try to convert it into this convolution, I would try to talk about this very important thing I will want to mention is how to calculate the parameters. Okay, number of parameters. So when you try to map from the input or from a previous layer to next layer. Okay, so wait. I've already talked about the function of convolution. Yes. Okay, now let's talk about No, I haven't finished. I forgot to talk about one more thing. Is when you need to use the convolutional layer, when you need to use the max pooling, when you need to use the flatten operation, when you use the fully connected layers, when you try to customize your CMM. Okay, that's the very important thing in the theoretical part. After we finish all this theoretical part, I talk about the parameters, calculation, etc. Okay, so when you use the convolutional layer, remember when we try to extract the features, okay? When you try, no matter when you fine tune your model, and no matter how you fine tuned it, you find that the information is underfitting. What's the meaning of underfitting? That means it cannot accurately, based on your current data sets, to find the clear relationship between your data set and the final targets, right? So if that's the case, you need to add the convolutional layer. So that's when you need to use the convolutional layer, because convolutional layer, it helps you to extract the features, okay? So when we settings here, they have convolutional layer, and more in deep, we try to learn the features like ages, textures, patterns, etc. But at the same time is the pattern parameter sharing. So this is what we say parameter sharing. When we try to map, for example, futures, okay? So this is what we talk about here, the futures. Futures is what we mentioned about the parameter sharing. So what kind of information, or to what extent the information you want to retain, you want to remain from the last layer, okay? So that's what we say, the parameter sharing. So for the parameter sharing, when you use the parameter sharing, it's the exact same as the previous. That means you want to obtain the information of the entire image as previously. So that's what we say, the parameter sharing, okay? If you reduce the number, that means you just need the part of it, okay? That's parameter sharing. Spatial hierarchy, I mentioned that previously about when you try to learn deeper information, or more detailed information, you just create deeper layer. And deeper layers need to be constructed with the convolution and max pooling, okay? So why we need max pooling? The max pooling, what we say, is try to, after the convolution 2D, they try to reduce the spectacled dimensions of the feature maps. So this is what we say, the max pooling, okay? Try to reduce it. Reduce the size of the feature maps could help decreasing the computational load and memory usage, okay? So that's the purpose that, why it exists and why you need to add the max pooling after the convolutional layer. And it also helps in making the detection features invariant to the small translations in the image, okay? And by adding the max pooling, because we say that when you add the convolution layer, you learn deeper information, or you learn detailed information. However, more detailed information will cause another problems. It did solve the underfitting problem, but it will cause overfitting problem, right? So if that's the case, the max pooling can help you to reduce the overfitting problem. Okay, so that's another reason why we need the max pooling. So when we need the flatten is before you feed the data into the dense layer, you normally need it, okay? So typically, after your last pooling or convolutional layer, you need to add the flatten. It could transmit to the fully connected layer. So flatten is only help you to transfer from the feature. So remember, convolutional feature extractions, dense is what? Dense is try to classify those features mapping into your final target, okay? And between these, the flatten operation is the bridge, okay? It's the bridge, okay? So fully connected layer is dense. I don't need to explain that why we need to use it. Okay, so that's it. All right. So now that's all the theoretical one I want to tell you. And now let's focus on about how to calculate the parameters. So let's focus on this. All right. So in your final examination, I normally give you a piece of like the program like this. Okay. So for example, I would ask you about, okay, so for the line 6, after after the previous features, what's the this layer's parameter? How many parameters it will occur for this layer? Okay, you need to first understand about this code. And second, you need to understand from this code how to calculate the parameters. Okay, so first of all, understand about this code. The layer is convolutional 2D, that's convolutional layer, max pooling layer, all right? So we have two convolutional layer with one max pooling, one convolutional layer with one max pooling. So this is its bottom, okay? And then so before the dense layer, we have the flatten to transfer the convolutional to the dense layer, all right? So that's how you're understanding about the whole structure. So after your understanding about the whole structure, let's focus on the input. What's the input means here? Shape 224, 2243, that means it's the image of the, the size of the input is the height 224, 224, and channel is 3. The channel 3 can be the RGB, can be the hex, right? Can be other, I don't mind, right? So after you understand this, the first layer is the convolutional layer. Okay, so following about this calculation, you will understand about how to calculate the first layer parameter. All right, so for the fifth length, it means this is the first convolutional layer applied to 48 filters, convolutional filters of the size. Kernel size is 11. Kernel size, that means the window size is 11 times 11. Okay, and with the stride is 4. It moves the filter by 4 pixels at a time. So that's the stride, or we say the step, okay? 4 pixels at a time. Padding means same. That means it ensures the output has the same width, width, and the length and the height as the input by padding the input. So I will show you here, okay? I'll show you here what the padding means. Can you see? It's clear. Let me. It's not clear. Uh-oh. Okay, well, it's great. Oh, okay, it's great. Okay, for example, this is an image, okay? The input image is the height is 442, and the weight is, what we say, the 442 as well, and the channel is 3, okay? And now the first convolutional here, okay? The filter, so first convolutional layer, the first CONV to D, okay, so we have its filter is 48. So that means when we put next, we want the filter remains only 48, okay. Second is kernel size. Kernel size, that means 11, that means 11 times 11. Okay, stride, okay, stride is 4, padding, same. Okay, what it means. So I will utilize this red pen to talk about this kernel size. So kernel size 11 times 11, that means this is 11 times weight is 11. Okay, so strike is 4, that means I calculate, so after I calculate this, I calculate 1, 2, 3, 4. So 4 pixels. So next move is, it's also in this line, okay, also in this line, but I don't have space to write here. So it's in this location, I have another windows, okay. So for each window here, I applied filter 48, and with its activation is what? Activation is red blue to pass the parameter, okay, to pass the parameter into this layer, okay, into this layer, okay. And then what's the padding means? The padding means, for example, after this 4, okay, so this is the 4 strides. After all 4 strides, maybe in here, okay, in here, the 4 strides. I don't have for the 4 strides, they might overput. The padding means same. That means this value is the same as this value. I just auto-filled with this value. And after I auto-fill this value, I pass into here. Okay, so that's how you explain about the whole stuff. Okay, so now how to calculate the parameters of one convolutional layer. So parameter of one convolutional layer, they actually have a pattern, and equations, okay? For example, I make it large. Convolutional 2D layers parameter calculation, okay? So it actually includes, it includes the, all right. It's just the light, okay, it looks better to me. Yeah, it looks better to me and you as well. Okay, so it have the kernel's height times kernel's weight times the convolutional's input, okay, and times one that's bias, and then times output, convolutional output. So this is the, okay. Now this is the equipment about how to calculate the convolutional layer. Okay, let's calculate, for example, this one. Okay, the first layer. First layer, what's its input size? Kernel size. Kernel size, height and weights that we can fill in here. The first one's kernel is 11 times 11 times C input. What's the C input? It's from here. Okay, for the line 5, the input is here. Okay, the input channel you can find previously. The input channel is what? 3. Okay, so it means times 3. Okay, and then plus 1, and then times. What's its output? What's its output? C output, convolution output is the future layer, the futures, 48. Okay, 48. So these two things is very difficult to find out. So that's why I use the red pen, 48. And now you calculate it. This is the 121, 363, 363, 364. What's the result of 364 times 48? And then, is there anyone help me? Three 64 times 48. I got it. It's 17472. Okay. Now let's check whether the first convolutional layers parameter, whether it's the 17472. Okay. As you can see now, it's 17472. Okay. So this is the parameters number. This is not I calculated. This is how the models do it. Okay, this is the model's caricature. Okay, now let's do the same things for here. But I want you to give me the answer. What's the for this second? This is the first. Okay, what's the second? What's the second layer's kernel size? 5. Yeah. So it's 5 times 5. times, what's this? What's the kernel's input for the line 6? Kernel's input? 11? No. What's the kernel's input? We find x here, right? And then what's the input of this x? Think about it. This x input is the line 5's x output, right? And then what's this line 5 x output, C output? What's this C output? 3? No, 3 is the 4. 3 is this output, this inputs. Okay, now I know this will be very confused. That's why lots of students lost marks from previous. Okay, now let's check. Okay, for this x, C in is this outputs. This inputs output. Understand this part? And this C's output is 3, right? So this 3 is next layer's C in. And filter is this layer's C out. And this C out X is transferred to here. It means this C out is this C in. Got it? Okay, so now tell me for this line, what's the C in? What's the C in for this line? What's the C in for this line? The C, yeah, it's previous C out. What's the value? No, that's the number of parameter, right? Yeah, 48. You can consider this C is channel. You can consider this is a channel. Okay, so for, I want to change here. Okay, so for this input, the channel is 3, right? For this X, line 5X, the channel is 48, right? And for this, the channel is 1 to 8. And last layer's channel is this layer's input. And this layer's channel is next layer's input and this layer's output. Okay, got it. Right, now we calculated with this one times 1, and then we times what's the C output for this layer, for the second convolutional layer? Yes, 1 to 8. Okay, now we calculate it. It's 5, 5, 25, 48. Oh, okay, I need to use my calculator. Never mind, I can do this here. 25, 5, 5, 25, 48. It's 1200 plus 1 is 1201 times 128. All right, 128 is, I don't want to calculate it. 1 times 128 is 153 to 728. Now let's check whether it's, yes, it's 153728, right? So this is how you calculate the parameter. Okay. All right, so this is how you calculate the character. It's the convolutional layer parameter. All right. Convolutional layer parameter. However, convolutional layers parameter is different from the dense layers calculator. Okay, the dense layers calculator, they are different. So for example, this dense layer, why they are different? From nature, convolutional layer, it's what? It's feature extraction. You increase the dimension. The channel is increased from 3 to 48, right? From 48 to 128, right? However, dense layer is just one flattened. Remember, before the dense layer, we always have a flattened layer here. So we have already flattened it into the 1D vector. And the dense layer is actually 1D dense layer, right? Then how to calculate the dense layers parameter? It will be totally different, okay? So the dense layers, the dense layer, anyone can understand about, because it's different, and then you understand about their dense layers parameters? Stop it. I don't have time to. I just directly give you the calculation. Okay. Dense layer. Yes. I'm calling dense layer parameter number. Okay. So for the dense layer, it normally will have the calculation is the number of your dense layer. Number of your dense layers input plus 1, that's bias, times number of your outputs. Okay, it's this. Is that clear? Yeah. Okay. Now, tell me for your first dense layer, what's the input of your first dense layer? This is the tough questions. I will not ask you during the exam because this is too tough. I just want to tell you how you estimate it. Okay. All right. So this input, it actually depending on its input x. Okay, x. And this x is because you have flattened it. It's you need to actually calculate from the output from here. From here. Max pooling means nothing. Okay, from here. However, from here you need to calculate from the above to here, right? So it's not easy. So let's directly consider about your second dense layer. The second dense layer. The input is your first dense layer. Then what's the N in? Does anyone know the N in? What's the N in? For the second dense layer, what's the N in? Anyone knows? Give me a numeric. So the second of the N in is 204A. Okay. Remember, this is just the unit, okay? Because they no longer have the features. Features is 48, right? The feature is, the convolutional feature is 11 times 11 times future, right? That's what we say. It's the kernels, all the parameter in this kernel, right? However, the dense layer is not a kernel. It's not 3D. It's not 3D. It's 1D vector after the flatten. So with 1D later, 1D vector, it actually mentioned that its unit is. I want to erase it. Okay. And then it actually mentioned its unit is 204A. And its input, this X, it's directly from this first layer. The first layer, it mentioned that its input is, its output is 04. 004A, right? So it means the first dense layer's output is second dense layer's input. That is the 004A times 1. And its output is 204A. Okay. And the parameter, let's just quickly calculate this. Is 204A plus 1 is 2049 times 204A. And that will be the 4,196,352. Okay, now let's check the parameter. Right? So that's how they calculate the dense layer and the parameter layer. Okay, so we only have one. This one is just to estimate, it's very important. Why the number of parameters is important? When you customize your model, it's not just what you want. Like I think it's not that accurate. It's underestimated, and I add more convolutional layers, and I add more filters in it, and I add large kernel sizes in it. No, that's not the things. Okay, the parameter will give you the limit. The large parameter actually means the large size of the model. Okay, large size of the model, or we say the large size of the parameter actually means the large computational workload. Okay, so it actually will show you whether your computer can affordable for your calculations. Okay, so this is why to estimate the parameter of your model before you utilize it, before you train it, is very important. And that's why I need to do this calculation. Okay, so because lots of students lose marks on this, I spend lots of time here. But I think it's important, it works, okay. Now let's go back. So that's the layers, all right. And okay, now let's talk about the convolutional layer. I will quickly go through it because I only have just more than 10 minutes left, okay. The convolutional layer take advantage of the spectacle nature of their inputs, learns features in an effective manner. So it mainly differs from the fully connected layers. So fully connected layer learns global patterns. So global patterns, it means it summarizes it and try to map it into the labels, right? That's why it's in the dense layer, and that's why it normally says in the final decision part. Convolutional layer try to learn a local parameter because it tries to enlarge the local things, like from 3-channel thing. They try to find it in like 3D into 4080 ways to try to learn more features. Okay, so that's why they try to learn the local patterns. Okay, so they try to learn the spectacle information. All right, so here the kernel size determines the spectacle size. For example, it's 3 plus 3 or 48 plus 48 in future. Future determines the number of learned features. For example, 32. Remember, when you set up the features, we normally set like 32, 16, 48. Don't ask me why. It just when they practice, they find all those all those figures are suitable for the image. Okay, so to compute the output, the convolutional layer particularly slice the kernel just through the inputs is known as the convolutional operations. And for each possible location, the output is calculated as dot product for each filter. So how to map a 3 to 48 with the dot product, okay? So the output have shade of the output, high output weight filter, and where the output H and output R are influenced by the further hyperparameter slice and padding. Okay, you can have a better understanding interactive with this visualization. I want to show you this, but I don't have much time. The two properties, the patterns they learned are translation invariant. After learning a certain pattern in any locations, CNN can recognize it anywhere, and a dense connected model will have to learn the patterns again for every new location. And this will make CNN data effective when processing the image because the virtual world is fundamentally translated invariant. And they learn the spectral convolution. For example, first convolutional layer, they try to learn small local patterns such as the age. And the second convolution, they would try to learn the larger patterns made of the features of the first layer. Okay. That's why we normally, the first we set up the features will be, for example, small size, 48 or 16. The second convolutional layer, sometimes we will set it more larger comparing to the first layer, first convolutional layer. And it allows the CNN to effectively learn the complex and abstract virtual concept. Why is abstract? Because you enlarge it. For 3D version, you enlarge it into the 4D. That's why it's very abstract. All right, polling layer. It downsample the output features, right? It operates similarly to the convolutional layer by spectrally sliding a window size, pool size. Max pooling will by return the max of the window at each location. So max pooling will try to reduce your computational workload, okay? Average pooling is try to returning the average of window at each location, okay? And most common choice is max pooling with the pool size to strike size to, which spectrally half the inputs. For example, the input size is 128, 128, 32, and the size will be the 64, 64, 32 after the max pooling with this parameter size, okay? All right, what we need, why not just remove max pooling operation, keep fairly large feature maps, we have to talk about that, reduce the number of parameters and induce the spectral feature hierarchies, okay? Training CNN, a common issue is have to training the CNN using the very few samples, and a few samples can mean anywhere from a few hundred or to, so this is like small size, okay? In your assessment too, we always give you the scenario, for example, they have the small size, we have very limited data sets, but we have the already similar, we have existing models to solve the similar questions. So how to use that model to solve your problem, okay? That's also your assessment too. The model we provided is the model that solve the the most visual language task. And for your industry's problem, it must have their difference in their problems, right? So how to modify that model, how to modify the clip model into your problem. So that's how it learns. That's why I mean it's very important. Strategy one is training from scratch. Of course, in your assessment two, you probably just need to use fine-tuning, okay? Not strategy one. You might need to use strategy two, data augmentation, and the strategy three, leverage pre-trained model. That's the option we choose for you. However, in your final examination, we will test you understand all those strategies, okay? So for example, first strategy is training from scratch just means you need to start with the randomly initialized weights. Okay, just initially initialize the weighting. It's not from the zero. But these strategies have lots of like drawbacks. For example, they might have overfitting because you only have few people in. You run multiple runs. That means these few people. These few examples cannot represent the whole distribution. So that means overfitting, and can only use a small CNN. If it's large, it's more even easy to overfitting. Results is relative low accuracy. Okay, so but what qualifies enough samples to train a model is relative. So in your final examination, I will give you a number of the features, and you need to inform me about your justification, whether it's limited data or not, why you think it's not enough data. Okay, so the data is enough. Is related to the size and depth of the model. So largest models will require more samples to train. So example is it's impossible to train a CAN to solve this complex problem with just a few tens of the samples. But a few hundreds can potentially suffice if the model is small and well organized, well recognized, and the task is simple. So for example, if it's only a 3-layer, then hundreds of the samples are sufficient. However, if it's a 4 or 5, hundreds of the samples may not be enough. Okay. So the second is the deep learning models are by nature high purposeful. So example can be you can take an image classification model trained on a large scale data set and reuse it on a significant different problems with only minor changes. Okay, so that's why we have the strategy 2 and 3. Okay, this is an example dog and cat. So for example here to classify there is a dog cat. As you can see, we have thousands of the model, and then it's quite fit for example 4 or 5 layers model. Okay. Now as you can see, I don't explain it one by one because it's quite similar what I showed you previously. Okay, except for this one, scaling. Scaling is just what we say the regularization. Okay, so for example, if the value is all the value from here is 1 to 10, and from there is the 300, then I just normalize it. Okay, so this is the rescheduling happens. So every value just divided by the 255. Okay, make it float type. So rest, they are the same. Okay, same. Compile, same. Don't have time to work on it. This figure is also important, but we have already talked about this previously. Just Manning asks you how to determine whether it's overfitting or underfitting. So as you can see, this is definitely overfitting. Okay, and strategy 2 is you need to train with. The main thing is like the problem is limited data, right? And then we solve the data problem, then we need to do the data augmenting. So the data augmentations will take approaches for generating more training data from existing training samples by augmenting the sample via a number of random transformers that yield believable looking image. Okay, includes random flip, randomly flip the image horizontally, or random rotation, rotate the image by a random degree value, and random crop random subsections of the image. So that's all the detailed methodology for your strategy 2. So for example, this is example about this is only the training sample, but I want more data related to this dog, and these are all the samples after the data augmentations step. All right. So these are the in Python. You don't need to do it manually. You can utilize this one to help you do augmentation. Sorry, I need to skip the coding part. Okay, strategy 3 is leverage the pre-trained models. Okay, pre-trained models is what we utilized in your assessment 2. Okay, if its original data is large and general enough, that's what we say the CLIP. The model we choose for you is large and general enough, so you can easily apply it in other features. So spectacle hierarchy features learned by this kind of like a model can act as a generic model of the visual world, and its features can prove the useful for many different computer vision problems, even though these new problems may involve completely different classes. So these are all the models. Is we can consider it as the generic, okay? We have already talked about the structure of AlexNet. The rest of it you can check by yourself, okay? But assessment 2 is not the simple vision, it's the vision language model, so not in here, All right. So this is the important, how you transfer it, how you do the future fine tuning. Oh, great. I have 5 minutes left. Okay. So here, as you can see, this is what we say the trained convolutional base. Okay. So you just use this one as your convolutional base and train the classifier. Remember, this is the convolutional and the classifier. So train the classifiers means what? Fully connected layer. Okay, the dense layer. All right. So when you obtain the model, the first thing what you need to do is to do the model summary. You check on this structure, right? And you do need to understand about, you need to keep their convolutional layer as the base. Okay, and you remove their trained classifier. That's the fully connected layer. Okay, for the previous that I showed you here, the fully connected layer, dense layer, we include 3, right? That means you need to reduce that 3 dense layer and only remain the convolutional as your base. Okay, so after you remain these, remove this, you add your dense layer, you create your dense layer. Okay, the previous one dense layer, maybe the output is only 3 labels, the final dense layer is 3. But for you, for your case, the output could be, I don't know, the number of labels, 5, okay, 5 classes. For example, swimming, bike, car, bus, what else? Flight, yeah. So that's 5, right? So, create your dense layer, and after you create your dense layer, but consider the input of your dense layer as the output of the previous trained convolutional layer, all right? And you remember the fine-tuning actually means you need to frozen the trained convolution layer because you don't want to rerun the parameters. You need to use the others parameter. However, for the dense layer part, or you can create the more, not just the dense layer, maybe you can create your convolutional layer, okay? But it depends, okay? You can try, depends. And consider their input informations as your, consider their output information as your input feature and try to further fine tune based on the limited data you have. Okay, that's what we say the feature, the fine tuning, you use the pre-trained model as your feature extraction method. Okay, now next is implementation. It's mainly about how to, for example, when you obtain the model, the first thing is you need to obtain the summary of its model, right? And after that, how to frozen it, as you can see. Consider this convolutional base as your input feature and follow with the flatten layer, change the dense layer, right? With your own dense layer. Drop out, just add some regularization to avoid overfitting issues. You can add the dropout or not, depends on your performance. Okay, so this is how to fine tune. All right, to see the results and to fine tune the data. Okay, unfrozen. So fine tune the Commonwealth's back. Okay, frozen, fine tune. Okay, so normally we will freeze the first few convolutional layer and retrain the last few convolutional layer and dense layer. All right, so that's normally what we do. Now, modern CNN. This is, I just give you a look. It's not, I don't have time actually, so. Oh, okay, just these 2 things. Residual connections represent just adding an input of layers back to the output. So it actually acts as information shortcut around the noisy blocks. So if you find that there were lots of noise, it's not just the unlimited so overfitting and underfitting issues, you can add these to fine tune your performance, okay? So if the network's too deep and optimizations may stop the working, so you can use the residual convolution to make it normalized and keep working, okay? The batch normalization is the same thing. It's all the segmentation. Also, the dropout is one of it. So batch normalization layer introduced that adaptively normalized intermediate activations within the network model. So you can use mean or variance change over time during the training. So this is try to reduce the internal convolutional fit. Okay. In practice, the main fact will be it help the gradient propagation and allows the deeper network. Meanwhile, prevent overfitting. Okay, so that's the batchel normalization works. All right, so that's all from this week. Good time. It's 3 o'clock now. See you guys tomorrow. Bye. Discard.